Hello everyone, welcome to IIT and GATE classes. This is lecture 3 on operating system, and in this lecture we are going to study a very important topic, that is types of operating system. Okay, so the very first type is batch operating system. So batch operating system was developed in around 1960s. Okay, it was developed around 1960s, and at that time hard disk was not there. So IO devices were punch cards. Punch cards were used for IO devices. Okay, and user cannot interact with computer directly. So imagine this is your computer. User cannot interact with computer directly. Rather, there was a operator in between. Okay, so between user and computer, there was a computer operator present. Okay. So user will give their program to computer operator, and computer operator will run that on computer. So at that time, uh, it was not easy to operate computers, okay, because operating system was not so much well developed. Like today, we can directly interact with computer, but at that time, in early 1960s, we cannot interact with computer directly. Rather, we need lots and lots of skills to interact with computer. So there was a specialized person called computer operator, which knows who knows how to operate the computer. So user who want to run their program like C program, Java program, and so on. Actually, Java was not there at that time, but Pascal, C, and so on. Whatever program they want to, you can say, run. Okay, they give that program in punch card, and that program was given to computer operator, and computer operator on behalf of user will run that program on computer, and output was also stored in punch card. Okay, so input to computer was given with the help of punch card, and output was also stored in punch card. So you can say that it is nothing but so a punch advance uh, after few years punch cards were replaced by hard disk. That's it, you can think like that. Okay, so punch card are just like secondary memory only. Yes. Okay, so it was long back. Okay, so it's and the main problem. Okay, so you can think that the main problem in batch operating system was presence of computer operator. Let me jump to the next slide. Okay, yes, pause the video, note it down. I will jump to the next slide. Yes, so the main problem, or you can say disadvantage. Disadvantage was that the very first was presence of operator. Presence of computer operator. That means user can't interact with computer directly. That is, user can't interact. Okay? User can't interact with computer directly. So you may wonder that, so sir, no problem. They are not able to, you can say, interact. So what? Okay, but there is a big problem. I will tell you. Okay, presence of computer operator. That was the disadvantage. That is, user can't interact with computer directly. User can't interact with computer directly. Okay, so why this was disadvantage? So imagine you have to be in a queue. Okay, so in queue at around 7 a.m. It was reality. Okay, in IITs and big institutes where computers were there. Actually, computers were not there in. Uh, they were not common like today. So there were very less computers. So in big institutes like IITs, there were computers, and around 7 a.m. You can say students or users of computer, they will make a queue, and they will submit their jobs in the form of punch cards to this computer operator, and by the evening they will get their output. Okay, so that was really hectic and very you can say very slow process. Okay, so now you want to run a program, you just type in and you just run it and so on. But at that time, you have to be in a queue at around 7 a.m. or 5 a.m. in the morning, and then you will get your output at around at evening. Okay, like 7 or 8 p.m. in the evening. So if there was a error and so on in your program, then you will come to know almost next day about that error, and you will correct it, and then again you will be in a queue at around 7 a.m. and so on. Okay, that was the very big problem. Okay, so computer operator was not at all, you can say, good thing. Okay, and the second disadvantage was CPU was idle most of the time. CPU was idle most of the time. Okay, why CPU was idle? See, first of all, let me tell you why we are calling it as batch operating system. We are calling it as batch operating system because uh, computer operator will take the punch cards of all the users, as I have told you. So at 7 a.m. in the morning, you will be in the queue, and computer operator will, you can say, take all the punch cards, and he will make a batch. Okay, he will take all the punch cards and he will make a batch. Okay, batch in the sense like batch of all C programs. Okay, batch of all C programs. So he will make a batch and then he will input that batch to computer. Okay. So what was the advantage? So the biggest advantage here was, see, imagine first you want to run a C program, then you want to run a Pascal program, and so on. So once you if you want to run a C program, then computer operator has to load punch card, of C compiler. He has to load punch card of C compiler, and then C program will be executed. And after that, he wants to execute Pascal program, then he has to load punch card of Pascal compiler, and then he can execute Pascal program, and so on. So it is hell lot of wastage of time. So better is you collect all the C programs and you just load punch card of C compiler. Okay, you just collect all the C programs and you once you load compiler of punch card once you load punch card of C compiler, and then you can execute all the C programs one by one. So that was you can say save of time. Like we make batches of computer science also, a batch of operating system, one batch of DBMS, one batch of say C language, one batch of compiler design, one batch of TOC, and so on. So teacher do not have to speak again and again. Okay, he need not teach TOC again and again because he has made a batch of say 100 students. So now 100 students will be able to understand TOC on a single go. That is the main advantage of making the batches. Same is the scenario here. Okay, so computer operator will make batch of all the C programs. Okay, and then computer operator will you can say load punch card of C compiler, and then all these programs will be executed. So he need not change punch card again and again for C compiler, then Pascal compiler, and so on. So a lot of time will be saved. This was, you can say, this was a small advantage. But again, I'm saying that CPU was idle most of the time. Why CPU was idle? See, if we have loaded a C program and C program needs IO. For example, you want to input two numbers from computer and you want to add these two numbers. So till you input these two numbers, human speed is very slow. Okay, we will type the number say 536 and we press enter, and then we press 329 and then we press enter, and then output will be shown on monitor and so on. So these things we have to do. So obviously, whenever a program, okay, let me jump to the next slide, then I will show you. Okay. So whenever a program needs IO, whenever a program needs IO means you want to you want to give input from keyboard and so on, keyboard input and so on. Okay. So for that period, of time, for example, keyboard input needs say 2 seconds. So for these 2 seconds, CPU was idle. CPU was idle. Actually, CPU speed is very high. You can imagine them that speed is in MIPS, million instructions per second. Approximately, it is CPU speed is measured in million instructions per second. Okay, so CPU speed is very, very high. That means 10 to the power 6 instructions per second. 10 to the power 6 is very, very high. Approximately 10 lakh instruction per second CPU can execute. Okay, and forget about 10 lakh. You need 2 seconds to input just two numbers. So in 2 seconds, around 20 lakh instructions can be executed, and you have wasted a lot of time. Now I think you have got the point. Okay, so CPU was idle most of the time because whenever program needs IO, so at that time, for example, you need 2 seconds to input values from the keyboard, and at that, for these 2 seconds, CPU was idle. Okay, and we do not want that CPU should be idle because CPU is the main, you can say, main resource of computer system, and it should always remains busy. So better idea should be whenever a program needs IO, CPU should be shifted to another job. Okay, CPU can execute other jobs. So, but this shifting was not done in batch operating system. Hence, this was one of the biggest disadvantage, that CPU was idle most of the time. Are you getting it? See,
when a program is executing, and here program needs IO. So obviously CPU will remain idle for say this much time. So it's better to CPU should not be idle. CPU should not waste time. At this moment, CPU can be shifted to another job, so it can execute some some other instructions of other program and so on. Okay, so this shifting was not done in your uh, batch operating system. So that was the one of the biggest disadvantage of your batch operating system. Okay, so I hope I have made the point clear. So these were the two big disadvantage. First, presence of computer operator. Second, CPU was idle most of the time. Okay, now I am jumping to next slide. Okay, so this is all about batch operating system. Then second, few advancements were made and the new type of operating system was developed called multi-programmed operating system. Multi-programmed operating system. As the name suggests, multi-programmed means what? Multiple programs. See, please do not think कि multiple programs will be executed on CPU. No, 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 no. CPU is only one. CPU is only one. So it can execute only one program. Forget about one program. I will say it can execute only one instruction at a time. It can execute only one instruction at a time. CPU is one. So obviously, if you have one brain, so you can think of one topic at a time. You may think that you are doing multitasking, like you are doing a phone call and you are doing some work also and so on. But in reality, when you are in a phone call, you cannot write something on a piece of paper and so on. Okay, so your mind is one. You can do only one task at a time. Okay, so you have to take a small pause from your mobile phone and you will concentrate on paper and then you will write and so on. Okay, so our mind is one. We can do only one task at a time. Okay, we can think that we are doing multitasking, but actually we are not doing multitasking. Okay, we are taking a small pause. Okay, and then from immediately while writing, you will take a pause and you will speak to the person and so on. Like that we do. Okay, so CPU is one. Only one instruction can be executed at a time. So do not think that multi-program means multiple programs will be executed. No, 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 no. Okay, so what exactly multi-program means? Multi-program means, see, this is your main memory. So multiple programs will reside in main memory. Program 1, program 2, program 3, program 4, program 5. So 5 programs are there in main memory. So multi-program does not means that multiple programs will be executed by CPU. No, multi-program means multiple programs will reside in main memory or multiple programs will be stored in main memory. Okay, multi-program means multiple programs will stored in main memory. Multiple programs will reside in main memory or will be stored in main memory. Okay, multiple programs will be stored in main memory. Okay, yes. And when CPU is executing one program, for example, P1 CPU is executing, and then this P1 needs IO. P1 needs IO. Immediately, CPU will be shifted to the next job or next process or next program. That is, let us suppose P2. And then when P2 needs IO, then it will be shifted to next program and so on. That is the basic scenario in multi-program operating system. So the key idea is whenever a program needs an IO, then CPU will be shifted to another job or another process which is in main memory. So multi-program means multiple programs are present in main memory, and whenever a program needs IO, then CPU will be shifted to another process or another job. Okay, so directly, indirectly, we have got the advantage here. Like here we were having disadvantage. The CPU was idle most of the time, but here I will say biggest advantage will be CPU will be never idle. CPU will never be idle. CPU will never be idle. Okay, because as soon as a job need IO or as soon as a process need IO, it will be shifted to next job. Okay, yes. So now there are some critical things which we should know. First thing is when a process is executing on CPU and it needs IO, so CPU will be shifted to another job. But which job will be executed next or which process will be executed next on the CPU? That is known as CPU scheduling. So CPU scheduling, concept of CPU scheduling was introduced in multi-programmed operating system. CPU scheduling. CPU scheduling means simply I can say which process will be executed next. Don't worry about these terms. I will explain them in much detail when we will dig deep into the topic of CPU scheduling and so on. Roughly, you can say when CPU is executing any job and it needs IO, then CPU will be shifted to another process. Now, which process will be executed next? That is CPU scheduling. So this decision-making process is known as CPU scheduling. Okay. Yes. So which process will be executed next? This decision making is known as CPU scheduling. You can note it down, please. I will write it here and then it will waste a lot of time. Please try to follow it. Try to note it down. Which program will be executed next? Which program will be executed next? This decision making process is known as CPU scheduling. This decision making process is known as CPU scheduling. Okay. Yes. And when multi-program OS were developed, at that time, hard disk were came into the picture. Okay, punch cards were replaced by hard disk. So at that time, hard disk was there, and obviously, size of hard disk is very large as compared to main memory. Like in today, also we have 1 TB hard disk, 2 TB hard disk, terabyte hard disk, na. And RAM is just like 4 GB, 16 GB, 32 GB, and so on. So there is a huge difference between the size of hard disk and size of RAM. We already know all these things. Okay. So now there are many jobs in your hard disk, okay, and only few jobs will come in RAM. Okay, so there are lots and lots of job in hard disk, and only few jobs will come in RAM, which will be executed by the CPU. Obviously, when a job is in hard disk, it cannot be executed. So it will be shifted from hard disk to RAM, and then it can be executed. Okay. So now which job from hard disk will come to RAM? This decision making is known as job scheduling. I have already told you about all these terms, basic terms, in the lecture 1 of operating system. That was about the basic introduction to us. In that I have already discussed, but I am just telling you that these terms were introduced in multi-program operating system. Okay, so there are many jobs in hard disk, and we want to select which job will come from hard disk to RAM. And I have already told you in lecture 1 that you can think that, sir, why we need to take decision? We can take randomly and so on. Then I have told you about job mix. Okay, CPU bound job, IO bound job. There should be proper job mix and so on. I have told you all this. Okay, so I will not dig deep into all these things. Anyway, when I will jump to the topic of job scheduling, I will give you more idea about all these things. Okay, so job scheduling means which job will come from hard disk to RAM. Okay, so if you want to write something, then I can tell you. Okay, I will not write the things because it will waste our time. You can write, since multiple processes can reside in main memory. Since multiple processes can reside in main memory, but main memory is limited. But main memory is limited. Okay, main memory is limited. So concept of job scheduling was introduced. So concept of job scheduling was introduced. So concept of job scheduling was introduced. And job scheduling means, which jobs from hard disk, which jobs from hard disk will come to RAM. Okay, which jobs from hard disk will come to RAM. Okay, roughly I have told you, that is more than sufficient. Okay, I am just dictating this a few notes so that you can note down all these things. Okay, and anyway, these are simple theoretical things. Okay, I'm not skipping the things. That's why I'm telling you the basic idea. Okay, yeah, please note it down, and I will jump to the next slide. Yes. Now, please try to think about disadvantage of multi-program operating system. What was the disadvantage of multi-program operating system? So the very first and very biggest disadvantage was process will voluntarily release the CPU. Process will voluntarily means according to its own will. Whenever process wants, only then it will release the CPU. Okay, so CPU cannot be snatched from any process. That was the biggest idea. So process will voluntarily release CPU. And when it will release it, when process needs IO. So when process needs IO, okay, then it will release the CPU, and it can be given to other tasks and so on. So process will voluntarily release the CPU. So So why it is a disadvantage? Because if process will voluntarily release the CPU, then user interaction cannot be done. User interaction with process cannot be done. User interaction with process can't be done. That was the biggest disadvantage, because if user want to interact with process, then obviously CPU must be snatched from the process and it should be given to the you can say control should be given to the user, so that it can type in something, and that command should be given to the process and so on. Are you getting it? See, this is a process. Okay, this process is running on CPU. Now user wants to give some command to the process. So obviously, how user will give command to the process? So user will type in command, and that command will be executed by CPU. Now, how that command will be executed by CPU? For example, you want to say you want to kill the process. Okay, you want to kill the process. So for killing, actually there should be piece of code. Nothing is done automatically. There should be piece of code, and that code will be part of kernel, which should be executed, and then the process will be killed, and so on. Are you getting it? So the key idea here is you want to execute another piece of code, and that code cannot be executed because process will not release the CPU. I'm just giving you a small, or you can say rough hint about what exactly is happening here. So that's why user interaction with the process can't be done. Okay. So user cannot interact with the running process and so on. That was the biggest disadvantage. Okay. Because for user interaction, a small piece of code should be executed. Okay. And that code cannot be executed. Why? Because process will not release the CPU. Okay, so that is the biggest problem. So so if you are able to follow, it's okay. Otherwise, please try to remember this. User interaction with process can't be done. That's it. Okay, that was the biggest disadvantage in multi-programmed operating system. Okay, so next comes into the picture. Next advancement was done, and then we got multitasking operating system. Let me jump to the next slide. Okay, then comes the multitasking operating system. Multitasking, or you can say time sharing, multitasking, time sharing, or interactive systems, or interactive system. One and the same. Three names for one type of operating system, that is multitasking. Multitasking is also known as time sharing or interactive system. So what exactly is multitasking? It is simply logical extension of multi-programmed operating system. Okay. It is logical extension of multi-programmed operating system. It is logical extension of multi-programmed operating system in which concept of preemptive scheduling was introduced. Okay, so it is a logical extension of multi-programmed operating system in which concept of preemptive scheduling was introduced. Preemptive scheduling was introduced. Preemptive means you, we can snatch CPU from a running process. Okay, that can be done. But in multi-program, it cannot be done. But here it can be done. Okay, so in which concept of preemptive scheduling was introduced. Okay, so now since we can snatch CPU from the running process, so obviously user interaction can be done. So hence we call them as interactive systems. Okay, interactive systems because user interaction can be done. Okay, so user interaction can be done. So these are known as interactive systems. Let me write it here only. User interaction can be done. User interaction with running process can be done. Okay, but in multi-program it cannot be done. Okay, so and why we are calling them as time sharing? Why we are calling them as time sharing? Because according to time, CPU can be shared among the processes. Okay, so according to time, CPU can be shared among processes. CPU can be shared among processes. For example, we have P1, P2, P3, three processes in RAM. Okay, let me write it here properly. Okay, so let us suppose in RAM we have three processes, P1, P2, and P3. We have three processes in RAM. Okay, and this is a CPU. So CPU will execute P1 for say 2 seconds, and then CPU will be snatched from P1. Forget about it whether P1 was completed or not, whether P1 released the CPU or not. I really don't care. I will simply snatch the CPU from P1, and then I will give that to P2. So P2 will run for 2 seconds, and then I will give to P3. P3 will run for 2 seconds. Okay, and then again P1, then P2, then P3, and so on. So this cycle will be repeated again and again. So hence I have written that according to time, CPU can be shared among processes. That's why we call it as time sharing operating system. Okay. So I hope I have made the point clear. So nowadays, multitasking operating systems are developed. Okay. So user can interact with the running process and so on. Like you are playing a video game. Okay. So playing video game, that means a video game is a process because it is a piece of code which is running on your computer and you are interacting with it. You are giving some input to it immediately and it is responding to your input and so on. So these video games concept cannot be done on multi-programmed operating system because user interaction is not allowed there. Okay, because process will not release the CPU. Okay, so CPU will be released by a process or program voluntarily. Okay, so I'm using the word program and process interchangeably. Actually, program is a piece of code, and when it is executed on CPU, then it will become process. Okay, don't worry about it. I will tell you detail about what process is and so on. Roughly, you can note it down. I have told you in previous classes also. Program under execution is known as process. You can roughly say it like. Okay, program is a passive entity, process is an active entity, and so on. But I will clear misconceptions and basic concepts in more detail in next class only. Okay, I will jump to the topic of process, and there I will explain you all the things properly. Okay, so actually, program under execution is not a process. Actually, there are lots of extra things in process and so on. Okay. Yes, please note it down carefully, and I will jump to the next step. So this was the third type of operating system, that is multitasking or time sharing. Second was your multi-program. First was your batch operating system. So three we have done. Now I will jump to the fourth type of operating system, that is multi-processing operating system. Multi-processing operating system, which is also known as parallel systems. It is also known as parallel system. So what is multi-processing operating system? See, as the name says, multi-processing. So we have multiple processes. So operating system which is managing multiple processors. Okay, multiple processors. Multi-processing means multiple processors are there. So operating system which is managing multiple processors, that is known as multi-processing operating system. Okay. Yes. So multi-processing means, see, let me give you a small idea. Okay, so we can have multiple CPUs, but all of them will share RAM and have same clock, and hence it is known as tightly coupled systems. Are you getting it? Multi-processing operating system means we have, as the name suggests. Okay, let me write it properly. Okay, so first point, as the name suggests, here we will have multiple processors. Multiple processors. Okay, so now next question will come to our mind, how these multiple processors will interact and so on. So all these multiple processors will share RAM. That means RAM is common, will share RAM, and their clock is also common. Clock common means, see, if all the processors are connected with 1 gigahertz clock, that means in 1 nanosecond we will have clock tick. So so all these processors uh, will have same clock tick. Their clock will be synchronized. Synchronized means, well, obviously it will be synchronized because there is only one clock and the same clock is managing all the processors. So in one tick, all the processors will do instruction fetch. In next clock, all the processors will do instruction decoding. In next clock, all the processors will do, you can say, execution and so on. Okay, fetch, decode, execute, and so on. So instruction cycle that will be done simultaneously. Okay, so same clock tick. The main idea is same clock tick. Okay, on one tick. Roughly you can say if time is 10 a.m., then according to all the processors, time will be 10 a.m. only. That means what? Same clock tick. Okay, clock is ticking same for all the processors. Okay, so I think I have cleared your doubts and so on. Okay, regarding the same clock. Okay, so when clock tick will in the next clock tick, instruction will be fetched. In the next clock tick, instruction will be decoded and so on. So all processors will do same kind of thing. Okay, so fetching, decoding, executing, and so on. All these things are synchronized properly. Okay, it's not like that. Say uh, like one tick is over for you can say one processor, and for other we have done two ticks, and for other processor we have done three ticks. That is not the case. So obviously for one processor for which we have done three ticks, that means what? Three ticks means three times clock has been enabled, or you can say fetch, decode, execute. So this processor is very fast, this is slow, and this is very slow. Are you getting it? So one tick here, and same time two ticks here, and here same time three ticks. For example, say with one processor we have attached 1 GHz clock. With another processor we have attached 2 GHz clock. With another processor we have attached 3 GHz clock. That is not the case. Okay, that is not the case. So in 1 nanosecond, I will say one tick here, and here in 0.5 nanosecond. No, it is not the case. So 1 nanosecond, one tick here, 1 nanosecond, one tick here, 1 nanosecond, one tick here. So all the processors will be attached either with 1 GHz clock, all the processors will attach either with 2 GHz, or all processors will attach with 3 GHz clock. Now I think everything is crystal clear and everybody have got the point which I want to convey to you. Okay. So since we have multiple processors and all these will share RAM and clock, so these are known as tightly coupled system. Let me write it with a new color. These are known as tightly coupled system. Tightly coupled system. Okay, and since multiple tasks are executed parallelly, because there are multiple processors, obviously you are having 3 to 4 CPUs, or you can have even 10 CPUs also. So all of them will execute their task independently. Okay, rather I should say dependently, because clock is same and so on, but they are executing tasks. That is the main thing. So hence parallelly they are executing. So that's why they are known as parallel system. So multiple tasks can be executed simultaneously. You can write it down. Okay, multiple tasks can be executed simultaneously, so they are known as parallel system. Okay, multiple tasks executed simultaneously. Multiple tasks executed simultaneously. You can write it down. Okay, that's why they are known as parallel system. Okay, and let me jump to the next slide, and I will introduce a few more terms here. Let me jump to the next slide. Okay, so there is a term called graceful degradation. Graceful degradation. Okay, what is graceful degradation? Graceful degradation means, see, we have multiple CPUs. So even if one or two CPU fails, so even if one or two CPU fail, even then no problem. Even then no problem. That means your entire computer system will not fail. Okay, even then no problem. Rather speed will decrease. Now, even then your system will not fail. Even then computer system will not fail, rather its speed will become little bit slower. Rather its speed becomes slower. Speed becomes slow. Okay, so entire system does not fail, only that its speed will become slow. That is known as graceful degradation. Are you getting it? So if we have multiple processors and one of them fail, overall speed of the system decreases, but the entire system does not fail. Okay, that is known as graceful degradation. Okay, entire system will not fail, overall speed of the system will decrease slightly. That is known as graceful degradation. Okay, so degradation is done, but that is done gracefully. That means slowly it is done. Okay, it's not like that entire system will fail and so on. Okay, yeah, so let me jump to the next slide. So multi-processing operating system are of two types. Okay, multi-processing system are of two types. Okay, first is known as symmetric multiprocessing, and second is known as asymmetric multiprocessing. Symmetric multiprocessing and asymmetric multiprocessing. Okay, so in symmetric, as the name suggests, all CPU will run same copy of operating system. All CPU will run same copy of operating system. So since all are running same copy of operating system, so none is senior, none is junior. That means all are just like peers. So like you are attending college, so your friends are your peers. Okay, so none of them is senior to you, none of them is junior to you. All of you are peers. So that is the scenario here. All CPU will run same copy of operating system. So all will act like peers. All are peers. Okay, that is none is junior, none is senior, none is instructing. So we cannot say like one of them is instructing to others and so on, because one is senior, one is junior and so on. That concept is not there. Name is suggesting as symmetric. Symmetric means all are similar. Asymmetric, as the name suggests, asymmetric means what? We will be having a big CPU called master CPU, and it will run operating system. Okay, and this master CPU will assign tasks to slave CPUs. Okay, slave CPUs will not run operating system. They will just you can say master CPU will give command and they will just execute them and so on. Okay, are you getting it? So we have a master CPU and it will assign tasks to slave CPUs. Okay, so example of this is mainframe systems. In mainframe system, this thing is done. Mainframe systems. Okay, master CPU will assign tasks to slave CPUs, and master CPU will run operating system. Who will run operating system? Master CPU. Slave CPU will not run. Okay, so example of symmetric. Asymmetric, I have given you mainframe systems. Example of symmetric. See, in today in today's world, we have technology is advancing day by day. So almost all operating system are you can say support symmetric multiprocessing. So all OS, almost all OS support symmetric multiprocessing. And coming to example, what are the examples? See, symmetric multiprocessing is everywhere. So forget about computer. We have in mobile phone we have octa-core processor, hexa-core processor, quad-core processor, and so on. So that is an example of symmetric multiprocessing. Octa-core, hexa-core, okay, quad-core, dual-core, and so on. So dual core means 2 cores, quad core means 4 cores. So we have 4 cores, and each core will, you can say, imagine like each core will execute its own copy of operating system, and they can execute their task independently. No problem in all these things. Like one core is doing one task, another core is doing another task, and like that you can imagine. So in today's world, almost all operating systems support symmetric multiprocessing, because we have in today's world we have quad core, octa core, and so on, like that. Okay. Yes. So now let me jump to the next slide. So what we have studied in your multiprocessing operating system, these are tightly coupled system, because RAM and clock are same and so on. Okay. Yes. So next is distributed operating system. Next is distributed operating system. So what exactly is distributed operating system? See, in distributed operating system, we have multiple autonomous systems like this, and they are connected with high speed LAN. Okay, they are connected with high speed LAN or local area network, and these are autonomous systems. Why we are calling them as autonomous systems? Because even if this network fail, they will keep on running. That means they are not dependent on the network and so on. They can run independent. That is the basic meaning of autonomous system. Okay, so and each and every system will is having its own RAM, its own clock, and so on. Hence distributed operating system is also known as loosely coupled system. Here we are in here we have shown tightly coupled system, but here we will say distributed loosely coupled system. Loosely coupled system. Distributed system is loosely coupled system because each CPU has its own RAM and clock. Okay, they are functioning independently. Each CPU has its own RAM and clock. That's why we call them as loosely coupled system. Okay, and here also we have graceful degradation. That means even if one system fail, then obviously entire system will not fail. Speed will decrease. That's it. Okay, so graceful degradation is in also present in distributed operating system. Graceful, you can note down all these things. Okay, graceful degradation is there in distributed operating system. Graceful degradation is there. Okay, and okay, so why we are doing this distributed operating system kind of things? We just want to avoid single point of failure. Okay, so information is distributed among all these nodes. Okay, and we do not want to have single point of failure. That's why we have distributed information among all these nodes. Okay, so so to avoid single point of failure, the main advantage is uh, to avoid or you can say in distributed operating system there is no single point of failure. Okay, but in centralized system we have single point of failure. One centralized machine fail, entire system will fail. But here if one or two nodes fail, entire system will not fail, rather we will have graceful degradation. That means speed will become slow. That's it. Okay, entire system will not fail. That is the main advantage of distributed operating system. So in centralized, one system central machine fail, then entire system fail, but here it is not the case. Okay, and here we have a function of location transparency. One term is introduced, location transparency. Location transparency means to access any, you can say, file or data, we do not need to know the location. That means on which node that information is present, we really don't care about. Location transparency means we can sit on any node like this. We are sitting on this computer. Okay, node means here computer, and we can access any information, and we will and it will come to our mind that entire information is present in this computer only, but actually entire information distributed among all the nodes. Okay, so this user will think that entire information is present in its computer only, but actually it is distributed among all the nodes. So that is the basic meaning of location transparency. Location transparency means to access any data or file, we do not need to know its location. Where exactly it is stored, we really don't care. To access any file, we do not need to know its location. Okay, or we can access any information without knowing its address. That is location transparency. Okay, to access any file, we can access any information without knowing its address. Okay, so now this is information about distributed system. So a very beautiful question will come to our mind: where exactly this distributed operating system is stored, on which node it is stored, and so on. So answer is very simple. Actually it is, as the name suggests, distributed operating system, so it is distributed among all these nodes. So how exactly it is distributed, let me tell you about that thing in the next slide. Let me jump to the next slide. Okay. So actually distributed operating system is having two parts. Let me write it shortly. Distributed operating system. Okay. Distributed operating system has two parts. One is known as microkernel. One is known as microkernel, and another is known as network management component. Network management components. Microkernel, you can say, is installed on every autonomous computer, and it is used to manage the overall resources like your normal operating system. So microkernel is installed on each and every node. Installed on each and every node. Each and every node. Installed on each and every node. Or you can say autonomous system. Node means autonomous system. And what it will do? It is used to manage resources of your autonomous system, or you can say it is acting like an operating system for it. Acting like OS of autonomous system. Okay, that is microkernel. And what is network management component? So it is used to manage the network. Roughly you can say it is used to manage the network. Used to manage the network. Like TCP IP protocol and so on, we can use them to manage your entire network part like this. We have to manage the network also, no? So that is managed by network management components, and these are also installed on each and every node. It is also installed on each and every node. Okay. If you want me to give some example of distributed operating system, then I think you can guess. One of the best example is uh, distributed Unix. We have Unix. Unix is centralized operating system. Please note it down carefully. Unix is not distributed operating system. Unix is centralized operating system. Why? Because we have a centralized machine on which your Unix operating system is installed, and with that machine we have attached some dumb terminals, and on those dumb terminals user will sit and do their task and so on. So why we are calling them as dumb terminals? Because these terminals have CPU. They do not have CPU. They have just monitor and keyboard. You will type in something and you will get the output and so on. So this user will think that entire processing is done here, but actually entire processing is done on this central machine only. Okay, so Unix is centralized operating system. It is not distributed. Okay, so example of distributed operating system is distributed Unix. Distributed Unix, which we call them as D-Unix. D-Unix means distributed Unix. Another is Amoeba. Okay, another is Galaxy. Okay, so these are some examples of distributed operating systems. Yeah. So let me jump to the next slide, and then we will study the last type of operating system, that is real-time operating system. Let me jump to the next slide. Okay, so distributed operating system was your, I think, fourth type of operating system. Oh, sorry, fifth. It was the fifth type of operating system, distributed. Okay, and then we are going to start sixth type of operating system, that is real-time operating system. Real-time operating system. Okay, so see, real time, as soon as this we want to do something in real time. Real time basis means time boundaries are very fixed or very stiff. So they are used in those scenarios where we have strict time boundations. Okay, used in those scenarios. Used in those scenarios where we have strict time boundations. Strict time boundation. Okay, strict time boundation. Okay, so actually real-time operating system is of two types. RTOS. I am writing shortcut. Okay, real-time operating system is of two types. One is known as hard real-time system, and second is soft real-time system. Hard real-time system and soft real-time system. Hard, as the name suggests, here time boundation is very strict. Time boundation very strict. Time boundation very strict. Okay, and here time boundation, as the name says, soft means time boundation not very strict. Okay, not very strict. Time boundation is not very strict. Very strict. Okay, but here time boundation is very strict. Okay, and here we have sensors. Okay, sensors will bring data to CPU. Will bring data, or input will bring input to CPU. Will bring input to CPU. So we will not rely on your keyboard and so on. User will not give input because that here time boundation is very, very strict. We have to do it in real time. So user will obviously waste a lot of time in typing and so on. So we will not rely on input from keyboard by user and so on. So here we have some sensors that will bring input to CPU. Okay, but here we have keyboard, mouse, etc. Okay, so here input is from keyboard, mouse, etc. Because time boundation is not very strict now. Keyboard, mouse, etc. Okay, so not very strict, time boundation not very strict means what? Even after deadline, okay, we can say time boundation or deadline. Even after deadline, we have some utility. Okay, so if we complete the task after, you can say, deadline also, it will not, you can say, it will not lead to a fatal error kind of thing. But here it will lead to a fatal error. Okay, so example, if when I will give you example, then you will get more clarity. I'm restricting myself for just few more minutes. Okay, please be patient. Okay, so hard real-time system means time boundation is very strict. Soft real-time system means time boundation is not very strict. So sensors will bring data, will bring input to CPU, but here input from keyboard, mouse, etc. can be given. Okay, because time foundation is not very strict. So deadline is not very strict. Deadline not very strict means what? Even after deadline, if you do the task, no problem. Okay, no, I will not say no problem. I will say it will not lead to fatal error kind of thing like that. Okay, so here hard disk is not there. Okay, but here we have concept of hard disk, etc. Okay, so hard disk is not there. So from where booting and so on will be done, that will be done from ROM. Okay, so we need high speed memory. We will not rely on hard disk because hard disk will be slow and so on, because we want to do task really very fast. That's why. Okay, now I will show you example, then you will get more clarity. Example is embedded system. Embedded system means, okay, so we have a system. In that system your computer is embedded. In that system your computer is there. For example, in missile we have a small computer, so that computer is embedded in a missile. Okay, and obviously sensors will bring data to the missile now, like in which direction it will go and so on. Sensors will do all these things, because if user keep on giving input, then obviously it will be very slow, and missile will may come to your own house also. Okay, so they may destroy your own military also. So we will not rely on users. So we will take input from sensors only. Okay, so on real time basis all things will be done. So if decision is not taken in real time basis, obviously missile launching will fail. Okay, and in your ventilators also that is done. Okay, so in missiles, I'm not writing, you can note it down. Missile launching system, in ventilators also. Okay, in ventilators I think you know, in ICU, intensive care unit, patient are on ventilators. It will supply oxygen to the patients. Okay, and if it does not supply on a real time basis, then obviously patient may die and so on. Okay, so there are very strict time conditions. Okay, so they are used for a particular application or dedicated application. That is hard real time system. Okay. And soft real time system example can be weather forecasting and so on. Okay, so if that is not so hard or not so strict. Okay. Yes, so soft real time system deadlines are not very strict, but here deadlines are very strict. Everything is time bound. Okay, so there is no concept of hard disk and so on. And sensors will bring input to the CPU. Okay, example is embedded systems like missile system, ventilators, and so on. In factories also we have, like in Coca-Cola factory, bottles are coming. Okay, bottles are coming, and on those bottles we have to apply the lid. So this lid will be applied by uh, this lid applying is done by obviously computer, and that will be done with the help of hard real-time system only. Because if user will keep on pressing the key, and then and then machine will apply the lid on the bottle, then obviously I think hundreds of bottle will go, and then one bottle user will be applied to lid, because user speed is not very fast now. User cannot press button on a very faster manner. So obviously we have sensors. So sensors will bring data, and they will come to know, okay, next bottle has came, so immediately machine will apply lid on it. And next again sensor will sense that next bottle has come, and then it will apply a lid on the bottle and so on. Okay, so everything will be done on a very faster manner. But if user will keep on pressing the button and then a lid will be applied, then hundreds of bottle will be left. Okay, because user speed is not very high. So that is again example of hard real time system. So it is used in factories also. Yes, that's it. So this is all about types of operating system. So this is here we have completed our first chapter, that was introduction to operating system. And in next class we will start our next chapter, that is process management. And in the next class itself I will give you idea about what is process, how it is created, and so on. We will done all these things in next class only. Okay. Yes. Okay. Thank you so much. Bye bye. And if you want to note this, please note it down. Okay. Thank you so much. Bye bye.